Okay, today we're going to be talking about the molar mass of a compound and how to solve for it. And it's a 5-step process when given a compound. So when you're given a compound, the first thing you're going to do is separate your compounds into elements. Now remember, elements are always those capital letters. So if you see multiple capital letters, you're seeing multiple elements. A capital letter attached to a small letter is an element symbol. So you got to make sure you're watching for those symbols. Then you got to determine the number of moles of a compound or an element. Determine the molar mass of elements. You're going to multiply your mole times molar mass of elements, and you're going to add them all up to get your new molar mass. Now, I know it sounds silly, and I know it sounds kind of complicated when you're putting all 5 steps together, but if you use these 5 steps to make the little chart I'm going to show you, and remembering that you always write your units down, you will get it right every single time. Okay, let's use these steps now to do a sample problem. So we're going to do the molar mass of calcium carbonate, CaCO3. So first step is to go ahead and separate compounds into elements. So we're looking at calcium carbonate. We have 3 different compounds or elements: calcium, carbon, and oxygen. So we do Ca, C, and O. And then I kind of break my chart. The next step is to determine the moles of the elements in the compound. Now, with calcium and carbon, there's no subscript. It's written one time, which means you have 1 mole. So I have 1 mole Ca, and I have 1 mole C. Now when I'm looking at oxygen, there's this 3 attached to the oxygen. This is called a subscript. We've talked about that before in ion compounds and covalent compounds. This 3 tells me how many moles of oxygen I have. So I end up with 3 moles of oxygen. And then I do the next part of my chart. The next step is to determine the molar mass of the elements. Remember, you get your molar mass from the periodic table. Now, I realize that all the periodic tables have slightly different molar masses. Do the one on your periodic table for either tests or midterms. I'll make sure that you all either have a standard periodic table or I tell you which molar mass to use so you're not worried about those slight problems in the midterms. So, if we look at calcium on the periodic table, it gives me a molar mass of 40.078. Now don't forget to write your units every step of the way, so it's grams per mole. If I'm looking at carbon on the periodic table, it gives me 12.0107 grams per mole. If I'm looking at oxygen, it gives me 15.9998 grams per mole. Now you could write, to be most correct, you could write calcium, carbon, or oxygen after it, but these are the grams per mole of each of these elements as listed on the periodic table. Now, the next step, number 4, is to multiply your moles by your molar mass. So if you're making this chart the way that I'm making this chart, it's this 1 times this 40. So 1 mole calcium times 40.078 grams per mole calcium gives me 40, I grabbed the wrong blue, I apologize, 40.078 grams calcium. Now if you're wondering how I end up with grams calcium, just like in dimensional analysis, the moles cancel out so you're left with the units of grams. So if I'm doing the same thing for carbon, 1 times 12.017 grams per mole, 1 mole times grams per mole leaves me with 12.0107 grams carbon. And if we're looking at oxygen, we're doing 3 mole oxygen because of the 3 subscript times this 15.998 grams per mole. Remember, it's grams per mole is like grams per every 1 mole. We just shorten it. That's why we can cancel it out, and I end up with 47.994 grams of oxygen. Step is to add up all the grams. So you're adding this column up together to get your final molar mass. So I end up with 40.078 plus 12.0107 plus 47.994, and it gives me 100.0827 grams per mole calcium carbonate, because we calculated the grams per 1 mole of calcium carbonate, and this is our new answer. And we box our answer, remember to put our right units, and we put our units for what element we are talking about to be most correct. Okay, trying to do another example, let's do barium hydroxide. Okay, so for barium hydroxide, remember the first step is to separate compounds into elements. And hydroxide, or OH, everyone wants to put together into one element, but it's two large numbers, so it's two elements. So we have barium, which is Ba, that is one element. O is a secondary element, and H for hydroxide is a third element. So we have BaOH, and then we go ahead and make the first part of our chart, which is just the elements. Then we can go ahead and make the second part of our chart, which is the moles. So looking at barium, there's no subscripts attached, it's just Ba. We've written it one time, so we have 1 mole of barium. We have 1 mole Ba. Now we're looking at hydroxide, and hydroxide's in parentheses, which means whatever number's outside of the parentheses distributes to what's in the parentheses. So we have 1 mole oxygen in the parentheses, so 1 times 3 gives me 3 mole of oxygen. We have 1 mole of hydroxide in the parentheses, so 1 times 3 gives me 3 mole of hydrogen. And then we finish up our next column. The next step is to find the molar mass of the elements. And again, I do that by looking at the periodic table. So I look at the periodic table. The molar mass of barium is 137.327 grams per mole. And the most proper way is putting mole barium, because that way you know what element it is, so that you can always match exactly what you're doing. And that's really important. For oxygen, again, it's 15.9998 grams per mole of oxygen. And for hydrogen is 1.00794 grams per mole. Hydrogen, again, these are all found on the periodic table. I realize that there's differences in all the periodic tables for, again, the final or a midterm or an assessment. I'm going to go ahead and make sure that either it's standardized or you're given the exact molar mass to use, or you're not getting off by fractions of these items. So remember, the next step is to multiply across. So we're going to multiply 1 times 137.327, which gives me 137.327 grams of barium. Because remember, the moles cancel out, so you're left with the grams unit. So you've got 3 mole oxygen, so 3 times 15.998 gives me 31. Sorry. Mrs. McGuire read my problem wrong. This should be 2, not 3. Pretend that Mrs. McGuire can actually read her problems. I read the 3. I distributed in my brain. I apologize. Mrs. McGuire misread the problem. It's the hydroxides, but it's the same. Instead of having 3, you would have the 2 because the 2's down here. I apologize. I apologize. I'm apologizing. This is why I often pre-write things. And then 2 times 1.006 gives me 2.01588 grams of hydrogen. Again, you're going to add these all up together, and you end up with 171.34 grams per mole barium hydroxide. Don't forget to box your bottom number, your final answer, and I apologize for misreading my own problem. I know it looked funny, but I just kept going with it instead of double checking, and I apologize. Okay, let's do a final example, and I'm going to double check all of my work. So I'm going to do aluminum silicate. And I'm doing this one to show you the different, like, right now we haven't had a number out front, or if we're doing a distribution, we've had all ones. So I'm going to show you how it works with multiple numbers. Doesn't really change much, so you just got to remember your steps. Step 1, separate all of your compounds. Separate all your compounds into elements. So we have aluminum, which is Al. Then we have silicate, Si, because you got that big S and the small I. Remember, the big letters separate your different elements. And then we have oxygen. And then you start your chart. Then we figure out the moles per element. So we have the subscript of 4 next to aluminum. So we have 4 mole aluminum. For silicate, we've written it 1 time, which means we have 1 mole silicate, but we have this 3 outside the parentheses. So we have 3 times 1, which gives me 3 mole of silicate. And then we have oxygen, which has a subscript of 4, and 4 times 3 is 12. So we end up with 12 mole of oxygen. Once we go ahead and finish up that row of our chart or our table or our setup, you go ahead and do the next one, which is finding the molar mass on the periodic table. So we end up looking up at aluminum, which is 26.981. Now don't forget to put your units in grams per mole of aluminum. We have 3 mole of silicate, and we end up looking at the molar mass of silicon, which is 28.055 grams per mole of silicon. And we end up with 12 moles of oxygen. And we look at the molar mass of oxygen, which is 15.9994 grams per mole of oxygen. Then we finish up our chart. And for our next step, we multiply across. We multiply mole times grams per mole, which gives me grams of that element. So we end up with 4 mole times 26.981, which gives me 107.924 grams of aluminum. For silicon, we have 3 moles times 28.055 grams per mole, which gives me 84.2565 grams of silicon. And for oxygen, we have 12 times 15.994, which gives me 191.928 grams of oxygen. And just to quickly break this down, what this means is for every 1 mole of aluminum silicate, there's 107.924 grams of aluminum. For every 1 mole of aluminum silicate, we have 84.2565 grams of silicon. And for every 1 mole of aluminum silicate, we have 191.928 grams of oxygen. That's what that's breaking it down to. So that's why when you add them together, you get the molar mass of aluminum silicate, which ends up being 384.11 grams per mole aluminum silicate. Then you box your final answer, and that is how you conduct molar masses.